Assalamu alaikum and welcome to Mathcast with Faria Yusuf, and this is the second lesson of trigonometry. In the first lesson we discussed the basic angles and the sum of the values of the angles with respect to the basic angles. So in this lesson let's move on to the other three quadrants. So the other three quadrants, which means that we will be talking here about the first quadrant, which is from 0 to 90 degrees. This is going to be the first quadrant. Second quadrant is from 90 to 180 degrees. So if we are talking about the trigonometric ratios, then trigonometry being related to rotation, I can say that it has been rotated, the angle has been rotated so that it lies now in the second quadrant, anywhere in the second quadrant, meaning the angle value for the second quadrant can be between 90 and 180 degrees. Then we have the third quadrant, which is from 180 to 270 degrees. So that means from 0 degrees, it has been rotated up to the third quadrant, anywhere in the third quadrant having angle between 180 and 270. And then it is the fourth quadrant, which lies between 270 and 360 degrees here. So any angle which lies in the fourth quadrant will be having the angle between 270 and 360 degrees. So over here, I have started the explanation with respect to the basic angle, which is 30 degrees. Basic angles means all the angle which are with respect to the x-axis, they are called the basic angles. Like here, if I can see the rotation, it's 30 degrees here, and then we have the x-axis here. So this angle is called the basic angle. In the same manner, if we consider this angle here, then again a 30 degrees with respect to the x-axis. So in the second quadrant, this angle here is my basic angle, and starting from 0 degrees up till the rotation, up till the line here, which makes a 30 degrees with the x-axis on the negative side, that is going to give me the general angle. Starting from 0, meaning the complete rotation is the general angle, and the angle with the x-axis is called the basic angle here. In the same manner, I can have the basic angle in the third quadrant, meaning this angle here, which is, again, I've just taken an example of 30 degrees, and the general angle here will be starting from 0 up till the line of rotation. That means 0 up till the line of rotation. And then same can be done in the fourth quadrant. This here, with respect to the x-axis, is the basic angle. Starting from 0 up till this line, we can say we have the general angle here, meaning the complete rotation here will be the general angle. And obviously it will be between 270 and any value between 270 and 360 degrees. So if we are in the first quadrant, then it's no problem. We can say all the angles, they are between 0 and 90 degrees. So the basic angle will be equal to the general angle. But then if we move to the second quadrant, the third quadrant, and the fourth quadrant, the case is going to be a little different. Let's start discussing all the three cases. Second quadrant. Second quadrant, so if I have this rotation in the second quadrant, again I've taken the example of 30 degrees here, which is the basic angle with respect to the x-axis, then what I can see here is that my general angle is 180 degrees minus 30 degrees, minus the basic angle, 180 minus 30, which is 150 degrees. So this is my general angle, which is going to be 130 degrees here. Meaning in this case, in the second quadrant, I can say that if my basic angle is any angle which is theta, then the general angle will be 180 minus theta. The third quadrant, if I have this rotation in the third quadrant, then what I can see here is that this angle here is the basic angle. So again, I've taken the example of 30 degrees. So if this is a 30 degrees here, which is the basic angle, then the general angle starting from 0 degrees shall be 0, 90, 180, and then plus the basic angle. So I can say that the general angle here is 180 plus 30, giving me 210 degrees. So this is going to be the general angle, the value to get the general angle, the formula should be 180 plus theta. If the basic angle is a theta degrees in the third quadrant, then the general angle shall be 180 degrees plus the theta value. And then similarly in the fourth quadrant, what we can see here is that if this is my basic angle, 30 degrees, then to get the general angle, I should say that here it gives us the complete rotation, which is 360 degrees, and the general angle is 30 degrees behind 360. Therefore, I should say it's a 360 minus 30, which gives me the general angle as 330 degrees. So in the fourth quadrant, what we can see is that if the basic angle here is any value theta, then the general angle shall be 360 degrees minus the theta value here. So this is how we can get the general angle values in the second quadrant, the third quadrant, and then it's the fourth quadrant here. Now let's consider the signs of the three trigonometric ratios in the first, second, the third, and the fourth quadrant. So let's move on. First quadrant. This is my rotation in the first quadrant, making an angle theta. We know that for trigonometry, all the three ratios, sine, cosine, and tangent, they are given with respect to a right angle triangle. Therefore, I have this right angle triangle here. With this right angle triangle, obviously, we know that this is going to be my base, which is positive in this case, positive x-axis, positive base, and positive perpendicular because it's parallel to the positive y-axis. And then this line here is going to be my hypotenuse. So the sine theta is actually perpendicular over the hypotenuse, or we can say it's the opposite over the hypotenuse. Perpendicular or opposite is a positive value, therefore the sine theta needs to be a positive here. Cosine theta, it's base over hypotenuse. Base is a positive, therefore the cosine theta will be a positive ratio here. Tan theta, it's perpendicular over base. Both of them, they are positive, therefore tan theta here is going to be a positive. So what we see here is that if our rotation is in the first quadrant, then all the three values, all the three trigonometric ratio values, they are going to be positive. Therefore, in the first quadrant, all three trigonometric ratios, they are going to have positive values. Let's move to the second quadrant. Second quadrant, I have this rotation in the second quadrant. Basic angle is theta. Again, I have this right angle triangle. With respect to the right angle triangle, what I have seen is that my base lies on the negative x-axis and my perpendicular is lying on the positive y-axis, parallel to the positive y-axis. Therefore, if I get the ratios for sine, cosine, and tangent, then what I see here is that my sine theta is perpendicular over hypotenuse, positive value. Cosine theta is base over hypotenuse. Base is a negative, therefore the cosine will be having a negative sign. Tangent theta is perpendicular over base, perpendicular positive, base negative, therefore tangent theta shall be having a negative sign here. So what we have seen is that cosine and tangent in the second quadrant, they are having a negative sign, but our sine theta is a positive. Therefore, in the second quadrant, I can say that our sine ratio is going to be a positive, and cosine and tangent ratios in the second quadrant between 90 and 180, they shall be negative values. The third quadrant. Third quadrant, the rotation lies here, having an angle, basic angle theta. With respect to the basic angle, again, we have the right angle triangle. Base negative, being on the negative x-axis. Perpendicular also is a negative, being parallel to the negative y-axis. So again, sine theta, perpendicular over hypotenuse. Hypotenuse being neutral, it's always going to be positive. Perpendicular is a negative, therefore the sine theta here, the sine ratio here in the third quadrant will be having a negative sign. Cos theta, base over hypotenuse, base negative. Therefore, the cosine ratio will be having a negative sign here. Tan theta is perpendicular over base, negative over negative. That gives me a positive. Therefore, what I come to know here is that in the third quadrant, between 180 to 270, all the tangent values, they are going to be positive, and sine and cosine, they will be having negative signs. Therefore, in the third quadrant, my tan theta is going to be having a positive value. So, first quadrant, all the three ratios are positive. Second quadrant, sine is positive. Third quadrant, tangent is positive. And let's check the fourth quadrant. We have the basic angle here and the right angle triangle. Base positive, perpendicular is a negative. Sine theta, perpendicular over hypotenuse, perpendicular negative. Therefore, sine theta is going to be negative. Cos theta, base over hypotenuse, base positive. Therefore, cosine theta is a positive. And tan theta, perpendicular over base, negative perpendicular, positive base, giving us a negative sign here. So giving us a negative sign here, which means that the tangent here is going to be having a negative sign, and therefore it's just the cosine ratio which is a positive. Therefore, in the fourth quadrant, what we have seen is that the cosine is a positive and sine and tangent, they are going to be negative. Now, what we have seen here is that in the first quadrant, what we have seen here is in the first quadrant, all the three ratios, they are positive. Second quadrant, it's the sine which is a positive. Third quadrant, the tangent ratio is a positive. And the fourth quadrant, it's the cosine which is a positive. That means the trigonometric ratios, they are positive in two quadrants and negative in two quadrants. Meaning if we talk about sine, then sine is positive. Let's write it down also. Sine is positive, sine ratio, it's positive in the first and the second quadrant and negative in the third and fourth quadrant. In the same manner, the cosine ratio, it's positive in the first and the fourth quadrant, and it's negative in the second and the third quadrant. And for tangent, we can say that all the tangent values, they are positive in the first and the third quadrant, and it's negative in the second and the fourth quadrant. So sine ratio, cosine ratio, and tangent ratio, they will be having the positive and the negative sign assigned to all the four quadrants. And just to remember that, remember ASTC. A, the first quadrant, all are positive. Second quadrant, S, sine is positive. Third quadrant, tangent is positive, and fourth quadrant, it's the cosine which is positive. So just remember ASTC so that you will be able to solve all the questions regarding the equation solving for trigonometric ratios. So let's do some simple questions here. Now the question says, find the exact values of part A, sine of 120 degrees. So solving part A, sine of 120 degrees. So if I just sketch my rotation, then what I come to see here is that 120 degrees, that will be represented in the second quadrant. This rotation being between 90 and 180 degrees, it has to be in the second quadrant, so that here I can say that the general angle is 120 degrees. The complete rotation, the general angle is 120 degrees. So if this angle is 120 degrees, then I can see here that the basic angle then is going to be 180 minus 120, which shall give me a 60 degrees here. So this is going to be my basic angle. So if I relate the general angle to the basic angle, and it's in the second quadrant, so I can simply say that in the second quadrant, my sine is a positive. Sine here needs to be a positive, ASTC. Sine has to be positive in the second quadrant. Therefore, sine of 120 degrees, the complete rotation, the general angle, shall be equal to sine of 60 degrees here. And sine of 60 degrees here, we have already discussed, is under root 3 by 2. Therefore, I can say that sine of 120 degrees is just under root 3 by 2 here. Now, if the question says find cos of 120 degrees. So again, cos of 120 degrees, what I come to see here is that 120 degrees again is in the second quadrant, but we know that in the second quadrant our cosine is a negative. Therefore, I'll simply say that it's going to be equal to a negative cos of 60 degrees. Cos of 60 degrees is a 1 by 2. Therefore, I'll simply say that the value for cos of 120 degrees is going to be a negative 1 by 2. So by ratio, there is just a difference of the sign between cosine of 60 and cosine of 120 degrees, because now it lies in the second quadrant, and we know that in the second quadrant, the cosine ratio is a negative. In the same manner, if we talk about the tangent value, then for the tangent value, if they are saying find out tan of 120 degrees, again being the second quadrant, I'll say in the second quadrant tangent ratio is a negative. Therefore, I can relate it to the basic angle but with the negative sign, so that this becomes negative tan 60 degrees, or I can say that this value here is going to be a negative under root 3 here. So tan of 120 degrees shall be equal to a negative under root 3. So this is how we shall be solving the questions with respect to the general angles which may be lying in the second quadrant, fourth quadrant, or third quadrant, and so on. Let's do some more examples. Again, it's the same question, but find out the value, the exact value of cos of 225 degrees. So first, let's locate the quadrant. So to locate the quadrant, what I know here is that cos of 225, it shall be lying between the third quadrant, in the third quadrant between 180 and 270 degrees. So if the complete rotation here, the general angle here is 225 degrees, get the basic angle. Just remember, we will be relating general angle to the basic angle, and here I can say that the basic angle is going to be 225 minus 180 degrees. So 225 minus 180 shall be equal to a 45 degrees. So now I can say that the basic angle here is 45 degrees, and we are talking about the third quadrant. In the third quadrant, our cosine is a negative. Therefore, now I can say that its cos of 225, which shall be equal to a negative cos 45 degrees here, and cos 45 is a 1 over under root 2. Therefore, cos of 225 then shall be equal to negative 1 over under root 2 here. Let's do another example. Let's say find tan of 300 degrees. All right, so 300 degrees, it will be in the fourth quadrant between 270 and 360 degrees. So the general angle here shall be 300 degrees. So to get the basic angle, so the basic angle here, we shall say that it's a 360 minus a 300 degrees, giving us a 60 degrees, meaning the basic angle here will be representing 60 degrees. Now we are talking about the fourth quadrant, meaning this tan 300 degrees, I can relate it to the basic angle but with the negative sign, because in the fourth quadrant the tangent ratio is a negative, and I can say tan of 300 equals negative tan 60 degrees. So tan of 300 degrees then shall be equal to negative under root 3 here. So this is how we will be solving all these questions. Now, so after understanding the concept of locating the quadrant and then getting the tangent angle value, let's move on to solving the equations. So first we'll do some simple questions here. Solve each of these equations giving all solutions between 0 and 360 degrees. So this is the key word to underline here. They are saying it has to be between 0 and 360 degrees, and we have to give the answer to the nearest degree here. So giving the answer to the nearest degree, part A says, solving for part A, it says it's sine of x degrees, which is equals to 0.9. So just make sure that your calculator mode is set on the degree mode here. So I have to get all the angles between 0 and 360 degrees for sine ratio. So the first thing here is to locate the quadrant. So locate the quadrant. This is the first step that we have to do while we are solving for all the 4 rotations here. So sine ratio here is a positive. So what I know here is that I should be having my angle value in the first quadrant and in the second quadrant only, because sine is positive in the first quadrant as well as in the second quadrant. So x degrees here then shall be equal to sine inverse 0.9. Sine inverse 0.9 is a 64.15, meaning I have the basic angle with respect to the x-axis, which is a 64.15 degrees, and here it's 64.15 degrees. So this is going to be my basic angle. Let's not write it as an x, let's write it as our basic angle here. The basic angle. X we will be finding later with respect to all the rotations that we shall be having with respect to the sign given to us, whether it's a positive or a negative. So I have the basic angle, which is a 64.15. Now what I can see here is that the first angle is in the first quadrant and the second quadrant is in the second quadrant. Therefore, there are going to be 2 general angles, x values, and these are going to be in the first quadrant. Obviously, it's just going to be a 64.15. In the second quadrant, I should say that my general angle has to be 180 minus 64.15 degrees, or I can say that this here is going to be a 64, and because I need to get it to the nearest degree, so I'll say it's a 64 degrees, and 180 minus a 64 degrees here, which shall give me 116 degrees here. So these are going to be the 2 possible rotations. One is the first quadrant, and the second is going to be in the second quadrant. So these can be the answers for 2 general angle values here between 0 and 360 degrees for this question, for sine ratio, sine of x, which is equals to a 0.9. So then this is going to be the answer for this question. The second question here, it says find tan of x equals 0.25, and again we have to have it between 0 and 360s. We have to give all the solutions between 0 and 360 degrees. So tan of x equals 0.25. So part B, it says tan of x equals 0.25. First step, locate the quadrant. Second step, get the basic angle. And the third step, third and the final step, get the general angles here. So these are going to be the 3 steps which we need to follow to get all the angles for tan of x, which is equals to 0.25. So locate the quadrant, meaning if they are saying it's tan of x, which is equals to 0.25, I can see that it's a positive value. So locating the quadrant, I know that tan is a positive in the first quadrant as well as in the third quadrant. So I have located the quadrants. The angle values, they will be in the first quadrant and in the third quadrant where our tangent ratio is going to be positive. First thing, get the basic angle. So to get the basic angle, we know about what the basic angle is. Angles with respect to the x-axis. These are the basic angles. So to get the basic angle now, I should say it's the basic angle which is equal to tan inverse 0.25, or the basic angle then is going to be 14.04. Nearest degrees, it shall be equal to just a 14 degrees. So that means the basic angle is going to be a 14 degrees here and also a 14 degrees in the third quadrant. So to get the general angle, we know general angle in the first quadrant has to be the same, but in the third quadrant, this is how it's going to be. So to get these angles for x, I should simply say that the x values are going to be first quadrant, which is just a 14 degrees, but in the third quadrant, I should say it's going to be 180 plus 14 degrees, or I can say that the two angle values here are 14 degrees and 194 degrees here. So these are going to be the two solutions for this question where our tangent angle was a positive. Now the third question was regarding cosine, where it said solve, where it says solve each of these equations giving all the solutions between 0 and 360, and now we will be solving for cos of x, which is equals to negative 0.33. So cos of x equals negative 0.33. Let's start solving it. Cos of x equals negative 0.33, and we are solving it in the degree mode. So just be careful that all your angle values, they are in the degree mode here. Then we have to follow the steps. What are the steps? The steps are, number one, locate the quadrant. So to locate the quadrant, what I see here is that this cosine ratio has a negative sign. So if this has a negative sign, then it means that the rotation has to lie in the quadrant in which the cosine is a negative. So our cosine is positive in the first and the fourth, so therefore it shall be negative in the second quadrant and also in the third quadrant here. So this is how my axes are going to be. And in the second quadrant and in the third quadrant, I should be locating this rotation because our cosine has a negative sign here. First step is done. Now we have to get the basic angle. So to get the basic angle, we have done the part with respect to the negative sign. So when we are getting the basic angle, because it is with respect to the x-axis, so now we shall no more be considering the negative sign. In fact, we will simply say that it's the x value which shall be cos inverse 0.33. Again repeating, we are done with the negative sign because with respect to the negative sign, we have located the quadrants. It's in the second and the third quadrant. Now just find the basic angle. Basic angle is always a positive, therefore cos inverse 0.33. So the basic angle here comes out to be a 70.73, and here also it's a 70.73. Now I have located the basic angle. Now we have to move to the third step, which is to get the general angle. So to get the general angle, simply what I shall be doing is, I should say that now my x value shall be equal to, now in the second quadrant, the general angle, meaning it's the angle starting from here up till the line, meaning it should be 180 minus 70.73. So first angle, the general angle is going to be 180 minus 70.73, and then in the third quadrant, it shall be equal to starting from 0, this is where my general angle is, meaning now I can say it's 180 plus 70.73. So the second value that I should be having is 180 plus 70.73. So 180 minus 70.73 is 109.27, and 180 plus 70.73 is going to be a 250.73 degrees, or finally up to the nearest degree I can say that the angle values are 109 degrees, and approximately it should be a 251 degrees here. So these two are then going to be the solution for this question. So this is how we shall be finding out the angle values here. So let's solve each of these questions giving all the solutions. So the keyword is we have to give all the solutions from where to where between 0 and 2 pi, and our solution should be in the radian mode, correct to 3 significant figures here. So these are the keywords that I have underlined. So let's start working on it. The steps will remain the same. Cos of x equals 0.4. So cos of x equals 0.4. Switch your calculator to the radian mode if they have asked you to solve the questions in the radian mode. So this is the most basic thing that one has to do. You have to have the calculator in the radian mode now. Now cos of x equals 0.4. First thing, locate the quadrant. So to locate the quadrant, cosine here is a positive, meaning if I locate the quadrant, then it has to be in the first and the fourth quadrant where my cosine values are all positive. It's positive in the first quadrant, it's positive in the fourth quadrant as well. So this is going to be 0 radian, then it's a pi by 2 radian, then it's a pi radian here, then it's a 3 pi by 2 radian, and then finally this is going to be a 2 pi radian value. So cosine of x equals 0.4. We have located the quadrant. Now get the basic angle. We know to get the basic angle is always going to be with respect to the positive sign. So I'll simply say it's cos inverse 0.4. So that means my basic angle for cos inverse 0.4 is a 1.159 radian. Meaning I have the basic angle here, which is a 1.159. I have the basic angle here as well, which is a 1.159. So I have the basic angle. Now obviously I need to have the general angle. In the first quadrant, it will remain the same, no problem in the first quadrant. So I'll say it's x, which is equals to a 1.159, and in the fourth radian. And in the fourth quadrant, I should simply say that this value needs to be 2 pi minus 1.159. Meaning in the fourth quadrant here, it's starting from 0 degrees up till the line. So this is going to be 2 pi. It's a little behind 2 pi. So I'll say it's 2 pi minus 1.159 here. So the answer that I should be having up to 3SF, it's 1.159 radian, and 2 pi minus 1.159. That will give me a 5.125 radian. Now the question has asked us to give the answer up to 3 significant figures. So to give the answer up to 3 significant figures, I should simply say that the general angles here are 1.16 radian and 5.13 radian here. So this is going to be the solution for this question. The second part, it says tan of x equals negative 0.36. Again, remember the steps. locate the quadrant, get the basic angle, and then get the general angle. So tan of x equals negative 0.36, the first step. The first step is locate the quadrant. Now to locate the quadrant, I can see that my tangent value here has a negative sign. So I have to see in which two quadrants does the tangent ratio is a negative. So we know that the tangent ratio, it's negative in the second quadrant and it's negative in the fourth quadrant. So I can locate the quadrant and I can say that these are the two rotations in the second and the fourth quadrant here. I have located the quadrant. Let's write all the radian values, 0 pi, the axis values, 0 pi by 2, and then I have a pi, 3 pi by 2 radian, and then it's a 2 pi. So second step is to get the basic angle. Now we are done with the negative part. We have located the quadrant with respect to the negative part. So it's just that to find the basic angle, I'll simply say it's tan inverse 0.36. So tan inverse 0.36. Now that is going to give us tan inverse 0.36. That gives me the answer as 0.345 and 56. I'm taking it a little exaggerated values because I have to give my answer up to 3 significant figures. So here my basic angle is a 0.34556, and here also it's a 0.34556. I have to get the general angle, meaning starting from 0 up till this line, and then starting from 0 up till this line here. This means that the general angle values, they should be equal to pi minus 0.34556, and also it's going to be 2 pi minus 0.34556. So our angle values then are going to be, so solving for x, I can see that I should be having pi minus 0.34556, which gives me 2.796 radian. And also in the fourth quadrant, it's a 2 pi minus 0.34556, which gives me a 5.938 radian. I have to give the answer up to 3 significant figures. So up to 3 significant figures, I can say that 2.796 can be written as a 2.80 radian, and 5.938 can be written as a 5.94 radian, and then this is going to be the solution for tan of x, which equals negative 0.36. Let's do the last question, which is for sine of x equals negative 0.8. Solve for sine of x, which equals negative 0.8, and the question has already said that these values, they need to be between 0 radian. Our x values, they need to be between 0 radian and a 2 pi radian. So the first step to solve this equation is to locate the quadrant in which the sine ratio is a negative. So we know that the sine ratio is going to be negative in the third quadrant and also in the fourth quadrant here. So in the third quadrant and then in the fourth quadrant. So these are the two rotation values which we shall be having here. It's 0, 2 pi and pi by 2, and then it's a pi and a 3 pi by 2, and then finally a 2 pi. So these are the axes values that we have. We have located the quadrant. The first step is done. Get the basic angle. So to get the basic angle, we are simply going to say that it's x, which is equals to sine inverse 0.8. So the basic angle then, it's not, so the basic angle here, so it's going to be a 0.9273 radian. So I have the basic angle 0.9273 and 0.9273 here. I need to have the solution for the entire rotation, meaning the general angle, And we know that the general angle value here is going to be starting from 0 up till this line, which gives me a pi plus 0.9273. And it should be starting from 0 up till this line. So it should be 2 pi minus 0.9273 here. So let's get the general angles, and I will say that the general angles in the radian mode are going to be pi plus 0.9273 and a 2 pi minus 0.9273, and the general angles here are going to be, so pi plus 0.9273 gives me a 4.0693, and 2 pi minus 0.9273 gives me a 5.357. Now, rounding off the answer up to 3 significant figures, I should say it's a 4.07 radian, and also it's a 5.36 radian. So these are going to be the two general angles or the solutions for sine of x, which equals negative 0.8 here. So this is how we shall be finding out basic angles with respect to an equation, a simple equation given to us. So in the next video, we shall be doing some more questions from past papers. So thank you for watching, and Allah Hafiz.